Good day, everyone. I'm your professor on Principles of Steel Design. Our very first topic is to review the stress strain diagram of a steel material. No? Way back in your second year ba yun siya, you've encountered this one in Mechanics of Deformable Bodies or Strength of Materials, na mas commonly known as Strength of Materials. We really need to review this because this is one of the foundations for steel design. And mas itong diagram na ito is palagi nyo makikita ito sa ating subject na steel design principles of design. By the way, I am Ryan James is Olivo, Engineer Ryan James is Olivo, and I think, 'di ba, while I'm recording this one, nag Google Meet naman tayo and I've introduced myself to you, and now let's start our topic for this one. So first, ang pinaka simple way nito is to see this next slide, no? Suppose that a metal specimen be placed in tension compression machine. Anyway, nag-prepare ako ng video which is from YouTube. You can watch this in YouTube, but in this recording, you can pause this and you will first imagine this one, but may mas madali tayo and papakita ko sa inyo ang video. So, let's watch this video, no?
This is the test piece.
By the way, you can watch this video in YouTube and you can search it as Tensile Test now.
It has a cylindrical test region with an original diameter of 10 millimeters and an original gauge length of 100 millimeters.
This is the test specimen, and this specimen is a steel material now. This specimen has like earlier said, it has a diameter of D sub null or D sub 0 and gauge length of L sub 0, meaning ito yung original niya na length, ito yung original diameter. Then let's go.
Within this test region, distance marks have been drawn at regular intervals. They help to visualize and measure the plastic behavior of the specimen. Using a hand control, the tester moves the upper crosshead into its...
By the way, meron tayong ganito sa USM, no, doon sa may machinery banda. And we need to calibrate it first so that we can use it again, no? Meron tayong ganito doon. We call this UTM, Universal Testing Machine. Tinawag siyang Universal Testing Machine kasi it can be used as a compression testing machine. At the same time, it can be used as also a tensile testing machine. And if you modify this one, you can make this as a 3-point bending machine, yan, etc. But let's continue now.
Its correct starting position. Now he can place the threaded ends of the test piece in the lower and upper grips of the testing machine. In the next step, he swings the extensometer into its working position and checks that everything is correctly.
Like I said, like she said pala, no? This is an extensometer. Extensometer is a device that is used to measure the changes in the length of an object. Kasi itong UTM or Universal Testing Machine, ang mini-measure lang nito is the force, no? Kasi hihilain yan siya. Itong ends dito, itong ends dito, hihilain niya hanggang sa mag-elongate ito, no? Papahabain niya. So, we need another device called extensometer para siya yung mag-measure ng length, changes of length in an object. Let's continue.
Prepared. Then he selects all necessary testing parameters on the control computer. Ready. The test starts and the extensometer's sensor arms are carefully pressed onto the test piece. This way, the gauge length can be measured throughout the whole tensile test. The gauge length is displayed at the bottom right-hand corner of the screen. At the beginning, it amounts to 100 millimeters. During the tensile test, the test piece is slowly and constantly elongated.
So as you can see, no, dito sa graph na to, we have in the y-axis, it is the force, and in the x-axis, this is the change in length, no, delta L. This is what we call a force displacement diagram, but stress strain diagram is the most common, no? Yun ang ginagamit talaga natin. So how can we transform this in the stress strain diagram? The UTM measures only the force and the extensometer measures the position or the displacement, no? Ito yung original niya na let 100.0 and this is the force. We can transform this by you guess it, right? Force over area. 'Di ba merong given kanina na DO, D sub O, 'di ba? Yung tinatawag na diameter niya, yung ano niya, original diameter niya. So, ang gagawin lang natin dito is yung force, i-divide lang natin dun sa area, yung pi d squared over 4, di ba? May given tayo na d, original yan. Hindi yan magbabago at the course of this testing. So, kung ano yung plot dito, ganun din ang plus ng stress strain diagram. So, ano yung strain? So, ang strain is simple lang. Strain is just delta L over original length, di ba? Wala siyang unit. Meron tayong delta L. Ang delta L is the length, the new length, or L sub 2 minus the original length, yung L sub 0, divided by the original length. So, that is our strain. Kaya, matatransform natin siya in a stress strain diagram. So, let's finish this one. No? Hindi natin tatapos itong whole 8 minutes. I just want you to see kung paano kinukuha ang stress strain diagram.
With a standardized speed. The force that the test piece opposes to the imposed elongation is recorded and can be seen at the bottom left-hand corner of the computer display. The material behaviour can best be observed in a force elongation diagram. The force F is being plotted upwards on the vertical axis, the elongation delta L towards the right on the horizontal axis.
Napansin nyo, no? Meron tayo ditong force, and along this force, 0.69 kilonewton, meron na tayong change in length. That is 0.1 mm. Then, kita nyo kung ano itsura nito.
At first, the force rises rapidly. Force and elongation are proportional and form a steep, straight line in the diagram.
Lagi nyo tandaan yung sinabi ng babae. Force and elongation is proportional. And we can see that later. Why?
In this area, the material behaves elastically. If the test piece were to
The material behaves elastically.
be unloaded from this area, it would spring back completely to its original length.
If it is unloaded, it will spring back to its original length. And that is the elongation region. Elastic region, sorry.
In materials with yield point phenomenon, the end of the elastic area can be seen clearly. The plastic deformation starts abruptly and is accompanied by a sudden drop of force. If the test piece were to be
No? Malalaman nyo kung anong point ito mamaya and malalaman nyo kung anong region ito mamaya, malalaman nyo kung anong region. And I think, alam nyo naman ata yan from set of materials pa, no? This is just a review.
unloaded now, it would not spring back to the original length, but instead show a permanent elongation. In the next stage of the tensile test, an almost constant force level with slight fluctuations occurs. This phenomenon is called the Ludus effect. After a certain strain, known as the Ludus strain, the force increases again. The material opposes an increasing force against the imposed elongation. It strain hardens.
That is the strain hardening region. This is the strain hardening.
Up to the point of maximum force, the test piece is strained uniformly along its length. This means that the test piece gets longer and thinner but keeps a cylindrical shape. As soon as the maximum force is reached, a neck begins to form at one point of the test piece. All further
Necking.
the plastic deformation now only takes place at the neck, and eventually the test piece fractures there.
Diba? Kita nyo may curve. Meron ditong point na tinatawag yung pinakamataas niyan. We will know that one. Okay. Kita nyo, nag-necking na siya, oh. And pababa. Fracture po. Nasira na. In every testing, we really need to yung sa ganito sa UTM, no, may mga ibang testing na hindi sisira. In UTM, nasisira talaga yung specimen na ilalagay mo. For example, concrete, ito naman is steel, nasira siya. Kailangan natin putulin para malaman natin yung maximum niya na kaya niya. As you can see, this steel, no, naabot niya yung 28 mm na change in length. Delta L na elongation, naabot niya yung sobra 28, 29, siguro sa 30 na to banda. 35, 36 pala nandito.
In the recorded force elongation diagram, the force FEH at the upper yield point can clearly be seen. This is the highest force the test piece can sustain elastically.
Anyway,
FEF
nakita nyo na yung you can still watch this in YouTube, no? Just search Stencil Test by Material Science 2000. I'll just put the link here, no, when I uploaded our my lecture. Then you can still watch it. Then we can continue on this topic. No? Nakita nyo. This is the typical stress strain diagram, but sa kanya kanina this is force elongation diagram. So let's continue. You can read this, yun yung nangyari doon. In metallic engineering materials, napansin nyo, dalawa lang. It's classified as ductile or brittle materials. A ductile material is one having relatively large tensile trains up to the point of rupture. As you can see kanina, yung steel natin na specimen, meron siyang considerable elongation bago siya nasira. So what you can say that the steel material kanina it is a ductile material. Kasi matagal pa siya na nag-rupture, matagal pa siya nasira. Naka-create pa siya, kung baga sa chewing gum, no? Ma-stretch mo pa yung chewing gum before siya maputol, and you can say that the chewing gum is a ductile based on this description, di ba? Example ng mga ganun is like structural steel and aluminum. Whereas brittle materials are relatively small strain up to the point of rupture like cast iron and concrete. Napansin niyo yung pinagkaiba ng cast iron sa steel? Cast iron is a brittle material and steel is a ductile material. Kung cast iron ito, dito pa lang siguro basag na. Hindi na siya kayang may certain elongation pa to the point na mag-rupture siya. Likewise, ang concrete, ganun rin, no? If since it is a brittle material, dito pa lang siguro na point dito banda na point is basag na siya, sira na siya. That is a brittle material. Napansin nyo ng pinagkaiba ng ductile material sa brittle material. An arbitrary strain of 0.05 mm is frequently taken as the dividing line between these two classes. If it is less than 0.05, no, according to this, is that it is a brittle material. If it is almost greater than 0.05, then it is a ductile material. Ductile and brittle material. So as you can see kanina, no, nakita nyo dito sa picture. Ito siya. Ito yung na-plot ng computer based doon sa testing kanina, no, sa testing ito, di ba? Yun yung na-plot dito kanina. Ayan yung na-plot niya. No. Ito yung typical na nakikita nyo sa textbook, no? Yung makikita nyo sa strength of materials. And as you can see, meron tayong mga tinatawag na mga points, limits, papakalanan natin sila. So this is as the typical stress strain diagram of a medium carbon structural steel. So hindi ganito lahat ang stress strain diagram. This is for the medium carbon structural steel, are almost all steels. Ganito talaga itsura ng steel since steel is our topic, no? And steel is our course or subject, no? Kung sa concrete, hindi ganito ang itsura. Kasi walang considerable strain na naganap. Hindi niya kaya yung ganito ng steel because it's brittle. So this diagram is what we call a ductile stress strain diagram. So as you can see, meron tayong proportional limit. Malalaman natin maya ang meaning ng proportional limit. Meron tayong elastic limit. Ito yung pinaka nalilito ang mga estudyante nung pinagkaiba ng elastic limit at proportional limit. And we can see that later kung ano yan siya. Then we have yield point. Itong tatlo, ano itong pinagkaiba nila? Anong pinagkaiba? Then we have the ultimate strength. Then, may tinatawag na actual rupture strength and rupture strength. Anong pinagkaiba ng actual rupture strength saka rupture strength? since this is a stress. Nagkaroon ng ganyan because this is a stress, no? I'll give you a hint first, no? A hint. Paano natin i-transform yung F kanina to a stress? I-divide lang natin siya sa area, di ba? So, that's the hint. And you can see the necking. Napansin mo yung necking? Anong nangyari doon sa necking? I'll give you a hint also. Sa necking, yung diameter is lumiit. And if lumiit ang divisor ba yun yung sa ilalim, no? F over A. If lumiit yung A, tataas yung strength. And that is why meron ganito. So anyway, that is just a hint, no? We can proceed. Sorry, I'll make this as, as big as, So lagi itong tandaan, this is very, very important in steel design. And this is the very principle, this is very basic. This is very important in your board exam. This is where the steel starts. This is where the design codes, the principles of steel starts in this simple stress strain diagram. Kaya hindi natin to pwede baliwalain. And this was taught to you during the strength of materials. And I'm hoping na hindi nyo to pinagwalang bahala itong stress strain diagram because this is very, very important. Napansin nyo kanina yung sinabi ng babae, no? Meron tayong, nakita nyo yung proportion. Nakita nyo yung ito. Ito actual test na to, ha. Hindi ito drawing lang. Actual test talaga ito. Ito yung nilabas ng ano. Ito yung inilabas ng, napansin nyo? Hindi siya curve. Perfect linya siya. Diba? Pag may perfect linya tayo, may tinatawag tayong proportion. This is proportion. Big sabihin ng proportion, kung tataas ang force, tataas rin ang elongation. Depende sa kanyang slope. Diba? Diba? Ano yung slope? In your analytical geometry in high school. Now, this is proportion. So, si Hooke's law, noon pa yan siya, 1678, from the origin O to the point called proportional limit. The stress strain curve is a straight line. Pansin nyo? In actual experiment, in actual observation, from dito to dito, that is, nakita nyo, straight line siya, proportional limit siya. So, this linear relation between elongation and ductile force, pansin nyo, nakita yan siya ni Sir Robert Hooke in 1678. At, you guess it, tinawag yan sa apelido niya, Hooke's law. Kung may invento kayo na law, you can call it in your surname, di ba? That within the proportional limit, the stress is directly proportional to strain. Napansin nyo? Kung tataas ang stress, tataas ang strain. By the way, napansin nyo, why is it important to study stress strain? Kasi nga, in designing a steel structure, stress lang naman talaga ang loading. No? May loading kasi lahat ng material. Even its weight, it's called loading. No? So, let's back to our topic. Stress is directly proportional to strain. If nakakita kayo ng proportional symbol, no, meron talaga siyang constant. No? At tinawag itong the constant of proportionality K is called the modulus of elasticity E. Kasi si Young, inimbento niya Young, siya ang nakadiscover, no? By the way, ganito muna, a little history back, no? Even though if you know this one, si Hooke's law ang nakadiscover ng proportionality relation, linear relation of every material. No? Si Young's modulus naman ang nag-experiment. Sabi niya, totoo kayang sinabi ni Robert Hooke? So ako mag-experiment ako. So by experimentation, nahanap niya ang mga modulus elasticity ng different materials. And by the way, the most common modulus elasticity for steel, typical steel, is 200 GPa, meaning that is 200,000 MPa. GPa, MPa. Now, if you remember in strength of materials, di ba, meron tayong GPa, MPa, and na-review nyo naman yan. So, E is equal to the slope of the stress strain diagram. Napansin nyo slope, di ba? So, stress divided by strain, that is E. So, yun ang ibig sabihin ng proportional limit. it is the limit in which the stress-strain curve is a straight line. After that, hindi na yan siya. After the proportional limit, hindi na siya straight line. And sinabi dito kanina, meron tayong region. May region tayo dito kanina, part.
Point for nations these were to be unloaded.
Dito banda na part, this is the proportional limit. After dito na part, hindi na yan siya proportional limit. And Hooke's law is not applicable at this point, after this point. So this is the proportional limit. Lagi niyong tandaan guys, yung meaning ng proportional limit because baka maglabas yan sa board exam. Anyway, let's go back to ano. Basahin nyo na lang yung meaning niya, no? Elastic limit, no? Ano yung pinagkaiba ng proportional limit, elastic limit? Proportional limit is when the straight line ends, while elastic limit is the limit in which the material will no longer go back to its original shape. Diba? Napansin nyo yun? Ano ba ang mas mataas? So, after ng proportional limit, elastic limit na. If you stop the force, no, doon kanina sa experiment kanina, sa testing machine kanina, pag hininto nyo yung testing machine kanina, yung original length ng specimen, yung steel, hindi na yun siya babalik kasi na-reach nyo na yung elastic limit niya. If that limit is reached, yung material mo hindi na babalik. For example, may chewing gum kayo, balik naman tayo sa equal example ng chewing gum. Pag hinila mo yung chewing gum mabuti, hindi na yan siya babalik. But if you hinila mo lang yung bubble gum before its proportional limit, babalikin sa dati yung tsura. So, kanina, we have the elastic and plastic ranges. Now, this is what we call this is the range. This is the plastic range. The elastic range from 0 to E. Elastic range yan. And from E to the rupture strength, that is the plastic. Tinawag siyang plastic kasi ang plastic, it is a term used na antonym siya, na kabaliktaran siya na elastic. Kasi kung elastic, babalik siya sa dati yung tsura. Ang plastic, hindi na. So, napansin nyo, from O to P, from P to R. So, ano naman ang yield point? Yield point is the point at which the material will have an appreciable elongation or yielding without any increase in load. Ito yung pinagkaiba nilang tatlo. Proportional limit is where the linear, yung linya, or the Hooke's law stops. Elastic limit is the limit in which the material, after tanggalin mo yung force, hindi na siya babalik sa original niya. And what is yield point? Yield point is the appreciable elongation. So, ibig sabihin na appreciable, yan na yung nag-elongate siya kahit kunti lang na force ang ilagay mo. Kahit hindi mo na-increase ang load, nag-elongate pa rin siya. That is where the yield point starts. No? Maraming nalito dito. And now, I think, naintindihan nyo na anong pinagkaiba nitong tatlo. Proportional, elastic limit, saka yield point. So, napansin natin kanina dito sa video. Tingnan natin ulit.
Loaded now, it would not spring back to the original.
Napansin nyo? Haba ng haba. Pero yung 27.35 niya, yung force niya, wala nagabago. Grabe ang haba niya, oh. Iba ko muna. Pansinin nyo. Dito sa Y, tingnan nyo kung tumaas ang point. Tingnan nyo kung tumaas ang force.
If the test piece were to be unloaded now,
Tumaas ba ang
it would not.
force? Hindi. Tumaas ba ang elongation? Yes. From this point onwards, this is what we call a yield point. Common meaning ng yield is parang nag-surrender na siya. Napansin nyo, walang pagbabago sa force, pero grabe ang pagbabago sa elongation. Wala siyang pagbabago sa force, pero may appreciable elongation siya. In which there is also appreciable strain kasi wala namang problema. Fix man yung L, fix man yung area. So, tawag nila natin stress strain diagram. So, napansin nyo, dito pa lang sa experiment, naintindihan natin yung difference ng tatlo. Yield point, proportional limit, and elastic limit. Let's go back again. And ultimate strength. The maximum ordinate, meaning it's the maximum sa y-axis na kaya ng steel. Pansin natin, hanapin natin dito saan ang ultimate strength. Forward ko lang.
In the recorded.
Okay. the maximum ordinate. This is not the maximum ordinate. This is not the maximum ordinate. Nandito yan siya sa part na yan. Meaning siguro nasa 35. Nandito banda sa 35. Kung straight mo yan siya, lagi mo ng straight yan. No? That is the ultimate strength. Ibig sabihin yan, yung pinaka-ultimate niya talaga na strength, no, ng material na yan, and in this case, steel. Diba? Ganun lang kasimple kanina na ultimate strength, maximum ordinate. Rupture strength. What is the rupture strength? It is the strength in which the material rupture. Obviously, this is the rupture strength. Dito banda. Kung ilan yung force dito, like for example, this one, balik na naman tayo dito, this is the rupture strength. So, anong rupture strength niya? 24. Pansin nyo, 24. 24. Tama. That is the rupture strength. That is the strength of the material at rupture point. So, easy lang, di ba? No? So, what is the modulus of resilience saka modulus of toughness? Ganito na lang, mas madali yan siya. Resilience is in the elastic region, while toughness is the whole stress-strain curve. So, ganito lang yan, madali lang yan. So, modulus of resilience is just, no, sinabi dito is the work done. So, ano big sabihin ang work done? So, work is same with the energy, di ba? Newton meter, ganun siya. So, paano natin makuha to? Kukunin natin makuha natin itong modulus of resilience. It's just simple. Modulus of resilience is just the area under this elastic region. So, from 0 to P, that is the elastic region. It is the area of this triangle. Napansin nyo yung triangle na ito? Paano kunin ang area ng triangle na ito? Itong triangle na to. Simple lang, 1/2 base times height. Ano ang height natin? Ang height natin is stress dito banda. So, P, proportional dito, stress sub 2 minus 0. Height na yon. Anong base natin? Strain sub 2 minus 0. Yun na yung base natin. So, 1/2 base times height. Nakuha na natin ang modulus of resilience. Ganun lang. Kung maglabas yun sa board exam class, ito yun siya, yung area under the triangle. Sabi nyo lang, bigyan ka ng ganito, ng chart lang, ng diagram. Tanungin doon. What is the modulus of resilience? Yun lang, 1/2 the base times height. Wala na labot na dire. Wala na yan siyang pakialam dito na side because it's plastic range. Ngayon naman, ano ang toughness? Modulus of toughness. Lahat ng area dito sa buong curve na to. Lahat ng area from 0 to rupture point. Kunin mo lahat yung area na yan. I-shade mo. Yan, kunin mo lahat yung area na yan. Pero dito kasi na part sa plastic, hindi siya basta-basta madali makuha ang area niya, no? Kasi hindi siya triangle. Ito kasi triangle kasi proportional limit, linear pa, perfect linya, di ba? So, triangle siya. Triangle itsura niya, di ba? Pero dito kasi pwede nyo gamitin siya ng calculus or any other computing methods, no? By the way, hindi naman natin yung topic dito. But, yun na, you get my point. The difference between modulus of resilience and modulus of toughness is that one, no? This may be calculated as the area under the entire stress-strain curve from 0 to rupture. The toughness of materials is its ability to absorb energy. Ganito guys, kung lalabas sa board exam is may mga description tayo, no? So, ano pinagkaiba ng resilience? Its ability to absorb energy without creating a permanent distortion. So, distortion ang sinabi niya, hindi na permanent elongation, no? So, distortion na, parang nagbago na yung whole, no? Yun yung ability niya na mag-absorb ng energy. After this one, it's the ability to absorb energy without causing it to break. Meron tayong material, if you apply energy to it, no, kung hanggang saan ang kaya niya, yun tinatawag na toughness niya. Ibig sabihin ng toughness, ganun ang katapang niya. Sige, bigyan mo pa ako ng maraming energy. Bigyan mo pa ng energy. Kung hindi pa siya bibiak, toughness siya. Very tough siya. Yun na yung sabihin mo na kung mas mahaba ang stress-strain curve diagram, mas tough yung isang material. So, ano bang napansin nyo guys from that, ano? So, masabi nyo na ang ductile na mga materials is mas tough siya kaysa sa mga brittle. Kasi ang brittle, biak agad. Di siya makaroon ng appreciable elongation, di ba? Di ba? Di siya magkaroon ng, unless na lang kung yung ano nyo, yung brittle nyo is mahaba masyado yung linya niya, yung straight line. Diba? Mapansin niyo mas maganda talaga ang bakal compare sa concrete, 'di ba? Napansin niyo 'yun? Anyway, kung ano, common sense naman talaga, mas ano talaga ang bakal. Because the bakal pa lang doon sa stress strain diagram, kaya niya mag-absorb ng energy without causing it to break. Mas malaki yung area niya. Kasi may appreciable elongation siya. Yung mga ductile materials, may appreciable elongation. May makahaba pa siya before siya mag-break, before siya ma-rupture. So, masabi mo na tough siya, matapang. So, resilience naman, yung resilience, ano ba pinagkaiba ng tough sa resilience? Kaya lang yan mag-check sa internet ano meaning resilience sa toughness. Pero dito kasi, ah, yung, for example, mayroon tayong material. Pumbahan siya ng maraming energy. Ano bang energy? Makuha mo rin yan sa force, di ba? Force sa distance man lang yung energy, di ba? Yan ang pinaka-common na meaning ng force. No? Nakita niyo naman dito, may unit siya. So, NM, work done all over the area. It is area, volume. Kaya distortion na ginamit, permanent distortion. Ganun ka-resilient ang isang material. Ganun ka-resilient ang material. It is the ability to absorb energy. Kaya niya pa mag-absorb na energy na wala pa siyang pagbabago sa itsura niya. Pero pag, for example, bilagyan mo ng, ng energy siya, ang nangyari is, nag-iba na itsura niya, natapos na yung resilience niya doon. So, as you can see, sa resilience, hindi ka ano kagad based na kung mas resilient ba ang steel or ang concrete kasi doon man lang yan sa within the stress strain curve doon lamang yan siya sa proportional limit doon lamang yan siya sa yung sa linya di ba pero makasabi ka talaga na mas tough talaga ang steel di ba because mas malaki ang area niya mas malaki ang area kung kasi may area pagod ikaw plastic region ang sa concrete although may maliit siya na plastic region nun pero hindi masyado hanggang doon lang siya sa proportional limit na linya ganun lang makita mo sa concrete kasi brittle siya di ba ductile mas tough siguro based sa ano yan based sa stress strain diagram di ba marami tayong maano yan so, huwag niyo kalimutan tong meaning na to baka maglabas sa board exam okay working stress, allowable stress, at factor of safety. Ano pinagkaiba nila? As you can see, working stress from the word working, yan yung actual stress na material na binigay mo under given loading. So, ilagay mo yan siya doon, yung working stress niya, no? And meron tayong tinatawag na allowable stress. So, ano yung allowable stress? It is the maximum safe stress. Take note ha, safe. So, kailangan natin na hindi tayo maglampas dyan. Kung maglampas tayo dyan sa stress na binigay natin sa material na yun, hindi na siya safe. Oh, kasi mag-fail siya. Kaya yan ang ginatingnan natin parati guys sa design. Lahat talaga gusto natin ng safe. Kasi kung hindi safe, mahugno ang building. Ma-collapse ang building. Tama, di ba, no? So, the maximum safe stress that a material can create is termed as the allowable stress. Ano ba ang allowable stress? Continue. We'll continue this. Allowable stress should be limited to values. Ito yung mga pinag-usapan ng mga nagagawa ng code. For example, sa atin, National Structural Code of the Philippines, sila ang gumawa ng code na steel, nag-base nila sa ASCI, no? American Society for, ISEC, American Institute of Steel Construction, AISC, no? Sila nagsasabi kung ano yung allowable stress. However, no, napansin nila, yung allowable stress dapat sa proportional limit para ma-sure talaga natin na Hooke's law pa rin ang gumagana. Magamit pa rin natin yung E. Kasi pag hindi na siya Hooke's law, hindi na siya nasa proportional limit, hindi na magamit yung E, yung 200 GPa, yung Young's Modulus of Elasticity. So, importante naman yung Young's Modulus of Elasticity, iba. So, ang ginasabi nila, yung allowable stress, mas makita natin siya sa yield per ultimate stress. Kasi sa real life, hindi na natin mapansin yung proportional limit, kung saan may yung proportional limit, no? Ah, anyway, makita ko man yung yield point, yun na yung yield point, ano ba yung yield point? Yan na yung mag-start na may appreciable elongation na kahit walang increase in force. Napansin niyo? Appreciable elongation without increase in force, pinakita ko kanina. Or minsan yung ultimate strength. Ganito yan siya. Meron tayong tinatawag ultimate strength design. Yun ang bago ngayon. Hindi natin ginagamit ang yield point. Kasi pag gamitin natin yung yield point, mas magasto. Pero safe ang building. Mas magasto. Pero tayo is, since na civil engineer tayo, since na engineer tayo, ang meaning talaga ng engineer is to design with economy. Tipid. Hindi tayo magpagusto lang design. No, one story ang building mo, tapos palakihin mo yung column mo. Hindi naman yun siya masyado makatipid, no? Papagalitan ka ng kliyente mo. So, yun sabi nila, allowable stress is taken as either the yield point or yung ultimate strength. divided by a factor of safety. Now, so, ano ang factor of safety? Yun ang ratio niya. So, ultimate or yield. For example, ultimate kunin natin. Kunin natin yung ultimate strength. Ano ba yung ultimate strength dito kanina sa video? Ultimate strength niya is nasa 35. I-divide natin siya sa allowable strength. So, ano ba yung allowable strength natin? So, ibibigay yan siya, no? Hindi ako magbigay niyan. Nasa National Structural Code of the Philippines and or sa AISC na code, yung American Institute for Steel Construction. Anyway, meron tayong example dito, no? The following data, uh, review lang naman ito, no? Review lang naman ito. Area A, given is 14 mm, 50 mm, no? Kita mo. So, paano kunin? Ang strain, elongation, threat. Napansin nyo dito, ang given is load sa elongation lang. Load, elongation load. From 0 hanggang 65,500, 65.5 kilonewton. Fracture na. Wala na, hindi mo na ano yung elongation kay sira na, basag na eh. Fracture na. So, makita mo pag sino yan. Ito yung sa laboratory result. So, paano natin siya i-transform as stress strain diagram? Divide mo lang. Pansin mo, elongation divided by length, load. Stress is load divided by area. Ito na itsura niya. So, ito yung given. Ito kasi talaga makuha mo. Hindi ka makakuha ng strain at saka stress. Ang makuha mo talaga load elongation. Elongation, ang gamitin natin yan, extension. Ayan kanina, extensometer. Yung load naman is yung force, yung UTM. UTM, yung kanina yung device na extensometer. Diba? Kailangan natin yun. So, kung may pambili kayo. Pero anyway, mayroon tayong USM, mayroon tayong UTM. Ito lang wala sa atin, kaya mahirapan tayo mag-curve ng stress strain. Pero anyway, pwede tayo makarequest yan sa kung marami naman pera ang gobyerno. So, ganito itsura niya guys, no? PL, proportional limit niya is nasa 246, ano ba to? MPA. MPA. Ang proportional limit niya, 246 MPa. Doon kasi nakita, pagkita, uy, nag-stop naman yung perfect line. Kita mo ang proportional limit. Nag-stop ang perfect line sa 246. Yan yung proportional limit, 246. Pag after 246, hindi na pwede ang Hooke's law. Hindi na pwede ang E, Young's modulus. Elastic limit, 260. Pag naglampas ka to sa 260 MMPa, meron kang isang steel, tapos 260 MPa ang kanyang napunta, based, kung ito yun ha, is elastic limit. Pag tanggalin mo yung load, hindi na siya magbalik sa dating tsura niya. Ano na siya? Na-stretch na siya. Hindi siya parang lastiko ba? Di bang lastiko? Kaya tinawag elastiko. Yield point. 270 ang yield point. Nag-surrender na siya. Sige. Hindi yung sinabi na nag-rupture siya. Nag-surrender na siya kay from the word yield. Nag-surrender na siya na, sige, maghaba na lang ako na maghaba kahit kunti lang yung load na ibigay mo sa akin. Ngayon, ano yung ultimate strength niya? So, ang ultimate strength niya is 441. Yan yung maximum stress. Napansin niyo guys na, if you, may subject naman kayo na sa computer, no, using computer to, ito yung mga halos common, 246 saka 441. Anyway, hindi ko naman yung ituro, no. Ah, malalaman nyo na lang yan sa sunod, sa subject nyo. Makita nyo 441 saka 246. Bakit may dalawang given yan? No? Is ano ibig sabihin ng FY, di ba? FY, minsan, force yield 270, depende kasi yan, no? Di ba? Then, the rupture strength. So, dito, pinakita dito ng nabiak siya, bumaba siya. Hindi pwede mas mataas parati ang rupture strength sa ultimate strength. Unless na lang, yung kanina nakita nyo, itong actual kasi ito kanina, yung sa hint ko, sinabi ko sa inyo. Nagtaas kasi yung ultimate strength niya kasi lumiit yung area. Pag maliit yung area sa F over A, tataas talaga ang stress, di ba? Di ba? Yun ang mangyari. Bakit siya nagliit? Dahil dun sa necking. Asan ba yung necking kanina? Ako yung necking ko sa inyo. Ito yung necking, di ba? Ito yung original niya na diameter, pero dito lumiit dito. Tapos, pag liit niya dyan, may maliit pa yan siya. Di ba kung i-stretch mo yung chewing gum, parang lumiit yung diameter niya. So, pwede ba yun mo yung F over A, pero yun yung yun talaga yung actual niya dapat pag i-consider mo yung original niya na original niya na i-consider mo yung sa necking niya na diameter. Yun. Pero anyway, hindi naman kasi tayo i-divide mo natin dun sa original niya talaga na diameter before necking, di ba? Kaya nilagay dito is ghost line lang. So, guys, I think this is the end of our review, no? Wala na tayo, natapos na yung end of the review. And I'm hoping na na-review kayo, na-refresh kayo ulit sa strength of materials. So, wait for my further instruction and wait for my videos. Dahan-dahan tayo. This is just a review. Masabi mo na tapos nyo na to sa strength of materials, but this is the most important. Hindi kayo makaka-design kung hindi nyo, ay makaka-design naman kayo. Sorry, maka-design kayo. Pero napakaganda kung naintindihan nyo yung basics. This is the most basic of all basic sa steel design. So anyway, uh, have a good day and thank you for listening, and announce na lang ako ulit sa group chat kung anong next natin gawin, and thank you. Goodbye.